Hello quick learners, this is Dr.C.S.Anita, Professor CSE RMD Engineering College. Today we are going to discuss about the basics of the tree data structure. What is a tree? The simple definition of a tree goes like this. A tree is a collection of nodes. A tree consists of a distinguished node R, which is called as the root, and 0 or more subtrees T1, T2, so on up to Tk, each of whose roots are connected by a directed edge to R. Now this definition is a definition of a generic tree. What is the meaning of a generic tree? A generic tree is a tree wherein every node in the tree can have any number of children. Now if you look at the diagram which is given below, this is a diagram of a generic tree. The triangular representations represent subtrees. T1, T2, T3 up to T10 are subtrees of this tree. Now what does a subtree mean? A subtree means it is a tree by itself. That is, T1 is a tree by itself, which means T1 will have its own root, T2 will have its own root, and so on up to T10 will have its own root. Now, the roots of all these subtrees will be connected by a directed edge to the distinguished node R. So, these lines which go from the root of T1, T2 up to the distinguished node R, these lines you call them as edges. So, this is the definition of a tree. Let us now see a few more important definitions. What is a leaf node? A leaf node is a node with no children. What is a sibling node? If two or more nodes have the same parent, then you call those nodes as sibling nodes. What is a path? A path is a sequence of nodes n1, n2 up to nk such that ni is the parent of ni plus 1. So we will discuss these definitions in detail with the help of an example so that you will have a better understanding. Let us first finish the remaining definitions. What is the meaning of length of the path? When we say a path is going to consist of a series of nodes, then the length of the path will be the number of edges that are on that particular path. Two more important definitions. What is meant by depth and what is meant by height? Depth of a node ni refers to the length of the unique path from the root to that particular node ni. Height of a node ni refers to the length of the longest path from ni to a leaf node. So these are the most important definitions that you need to always remember. Apart from this, you need to remember that if a tree consists of n number of nodes, then definitely that tree will always have n minus 1 edges. And when you take the case of a generic tree, a node can have any number of children. Now we move on to an example. Observe the given tree carefully for a few moments. Now let us answer a few questions. Identify the root of the tree. The answer is A. Question number 2. Who are the children of A? The answer is B, C, D, E, F and G are the children of A, because all of them are connected directly to A through edges. Question number 3. Who are the sibling nodes? B, C, D, E, F and G are the siblings. Why? Because all of them have the same parent A. Similarly, I and J are siblings. Why? Because both of them have the same parent D. So according to the definition of a sibling node, we have found the answer. Question number 4. Who are the leaf nodes? B, E, F, H, I, J and K are the leaf nodes, because as per the definition of a leaf node, a node which has got no children will be called as a leaf node. Hence, B, E, F, H, I, J and K are leaf nodes. Question number 5. What is the depth of C? Definition of depth: length of the longest path from the root to that particular node. So your root is A. From A to the particular node C, length of the path is 1. Hence, depth of C is 1. Question number 6. Height of K. According to the definition of height, height of a node is the length of the path from the node to the deepest leaf. As K itself is a leaf node, the height of K is 0. Now, I will give you a question. Find out what is the depth of the tree as well as height of the tree. Here you need to remember one point. When you are asked to find out depth of a tree is the depth of the deepest leaf. And when you are asked to find the height of a tree is the height of the root node. So according to the definitions which I gave you now, depth of the tree is 2, height of the tree is also 2. So which is the deepest leaf here? Deepest leaf is going to be H, I, J, K. So all of them are deepest leaves. You can identify the depth of any one and call it as the depth of the tree. So depth of H is 2, I is 2, J is 2 as well as depth of K is 2. Hence depth of the tree is 2. Now coming to the height of the tree, which is the root node here? A. So what is the height of A? Height of A is 2. Therefore height of the tree will be 2. Are you able to understand this clearly now? Now all the questions that we put forth with respect to this example, I am giving the answers in the next slide. So please refer to some more examples and try to identify answers for various questions so that you will be familiar with the basics of the tree data structure. Now we move on to a special type of tree called as a binary tree. What is a binary tree? Every node in a binary tree has at most 2 children. What is the meaning of at most 2 children? That is, every node can have either 0 or 1 or 2 children, not more than that. So if you look at the tree which is given below, the tree given below has at most, that is every node has at most only 2 children. If you take 8, the node 8, it has got 2 children, 3 and 10. If you take the node 3, 3 has got 1 child, 6. 6 has got 2 children, 4 and 7. 4 and 7 have no children, they are leaf nodes. Similarly, if you go on to the right subtree, 10 has got 1 child, 14, and 14 has got 1 child, 13, and 13 is a leaf node. So this is an example of a binary tree. So how will you identify a binary tree? You have to check whether every node in a particular tree has got a maximum of 2 children only, either 0 or 1 or 2. If that condition is satisfied, then you can declare your tree as a binary tree. Now let's discuss some of the applications of trees. Trees are used for manipulating hierarchical data, for making the searching process easy, for manipulating sorted lists of data. It is used for various router algorithms, and it is extensively used in the design of a compiler. So these are the main applications of trees. Now I give you this problem as an exercise. Observe the problem very carefully and try to identify the root, siblings, leaves, height of 4 and depth of 9. And give your answer in the comment section. So with this, I wish you all a very happy quick learning. Thank you and bye.